So now we are going to move on to the two national competition presentations. So I would like to invite up the Data Harbor team for the Net Zero Data Center in Stanford to present their project. And let me get it up.
Hi, my name is Eddie Love, and I'm a senior at Flat Tech.
Hi, I'm Z, and I'm a junior at Trumbull High.
Hi, my name is Alexandra, and I'm a senior at Trumbull High.
Hi, my name is Ishida, and I'm also a senior at Trumbull High School.
Hi, my name is Charlotte Rotelli. I am also a senior at Fairfield Ward High School.
So, as artificial intelligence increases, there are more data centers that are being built. So, as that is a need for innovation, concerns arises for the environment and also for the local communities. To combat that, we have decided to So, because most data centers use a lot of electricity and water, we have given the assignment to use a net zero data center, design a net zero data center that will not only reduce the amount of, and reduce the environmental impact, and also
Our net zero data center will reduce environmental impact and carbon footprint while also significantly improving the surrounding community through various factors that we will discuss later on in our presentation.
So to achieve that, we have decided to use Stamford, Connecticut as our site selection. In Stamford, Connecticut, it is a very urban community, a very urban area, very close to New York. And not only that, our governor, Ned Lamont, said that it was a very good hub to develop in. Yeah. To aid in our net zero mission, we have also decided to put our site on the Long Island Sound as it is a crucial process, and since data centers build a lot of energy and heat, we are using a process called seawater reverse osmosis desalination, which essentially harnesses energy, cools the water, and pumps that cooled water through the building so that it cools all the systems through it. So our site is on the Mill River, and because it is also on the Sound, it also has concerns of flooding. To combat that even a little bit, we are using soil that is called the sandy loam, and since it has a very since it has a very high range, and it remains stable in wet conditions. So because of that, we are using that soil so that it can combat the flooding.
And so for our precedent research, we took a lot of inspiration from that image over there, which is the Cincinnati Serpentine Walk, because we thought it kind of like flowed with the environment. And one thing we wanted to ensure is that because we were building this in a very urban area, we wanted it to look kind of discreet and kind of fit in with the area and flow, and not just be kind of like a big concrete square eyesore in the middle of a city. So we wanted to kind of go with that flowy aspect we saw here and incorporate that stuff into our design.
So kind of adding on to that, we also took inspiration from the Impression Tai Chi Theater, which, as you can see, is very integrated into the environment. It's a very green space that uses a lot of green roofs and green walkways to kind of hide the building and make it more discreet. And so we kind of took that as inspiration as we began our design process. So a lot of data centers are a large rectangle, and they house thousands of data servers. And so we knew that bubble diagramming would be kind of redundant because it would just be a bunch of data servers. So our main goal was kind of to make the structure look as interesting as possible, considering that it is in an urban environment. And so we initially explored the idea of creating an underground data center and kind of creating an upper area that is meant for the community. So when we were toying around with some of our ideas, one of the ideas that we came up with was a golf course, but we ended up kind of scrapping that and scaling back on our design to create this large urban park, kind of like in the Impression Tai Chi Theater, and moved away from the underground idea, but we'll discuss that later on in our design process. So when we wanted to integrate this into the environment, right? So we looked to the wind patterns of the area to see how we could use them towards our advantage, to harness the wind in the area and use it towards our net zero initiative. So while researching, we saw that typically in the winter, which is when the wind patterns are at their peak, the wind flows northwest from the Long Island Sound, and so we wanted to kind of highlight that through our canyon design. So we have these two large structures, and then we have the hollow line running through the middle, which will house turbines that will harness the wind and be used to generate energy for the net zero data center. And so this was our initial floor planning, where we would have this artificial hill that would house all the data centers, but then also could be used as a terrace for people to relax on. And then we would have the proximity to Long Island Sound would be used to pump cold water for the data cooling, since there is a lot of cold water within the sound. And so our initial floor plans, we realized that an underground design would not be possible because of the location. Since this is on the river, we knew that we didn't want to risk having these expensive data centers be flooded or risk water damage. So because of the soil type and the depth of the water at this point, we decided it would be too risky to excavate deep into this peninsula. So we began to explore the idea of having this artificial hill that could house the data center within it. And so our initial floor plans reflected that idea, which was shown up above, and we had 3 floors that stack upon each other to build a hilly area that could also be used as a park. And so this was also a sketch that one of my colleagues sketched up, and kind of inspired me to go into the direction of creating on top of this data center also a public space. And so we kind of explored the functionality of this public space later, but this public space would be raised elevated above the data center, and it kind of inspired our further design. So yeah, moving into what we actually wanted to use that circular space for. So in our initial floor plans, we kept kind of drawing this circular space in the center. And so we initially planned for it to be administrative facilities, but we kind of had the idea mid-design to include an interactive part of the building for the general public. Data science and AI has been a really emerging field in the past couple of years, and so we decided to create this, public museum informational space that could, teach the public about what these data centers are and what the importance of them in our modern day society. And so it takes on a circular shape, and it's accessed from elevators in the columns below. So in the conceptual design you saw in the slide previous, it was kind of this circular building with columns underneath it. And so it's going to have exhibits exploring the history of data science, moving chronologically from the inside out. So the outside exhibits will be the most modern ones, and then as you go towards the center, you're going to explore the origins of data science. And so we took inspiration from labyrinths as their places to walk through and meditate. So we wanted people who were coming to visit and exploring data science to just kind of walk through this museum and walk towards the center to explore the many uses of data science and become more educated on this topic. And so this was a conceptual drawing that I drew by hand. And so as you can see, there's a lot of these different terraces throughout the building, and there's stairs that kind of go between. So really highlighting our inspirations from our precedent research. So as you can see, this kind of took inspiration from the Cincinnati Serpentine Walk. And so that circular building up there is the Informational Data Center building. And so there's a waterfall that runs through the center of that, but I'll talk more about that later. And so those window spaces up there on the upper part of the hill, those are administrative facilities. And as you can see, there is a river that runs through this building, and it kind of circles back around to spit out into the Mill River. And so, yeah, this is a very integrated into the environment design with a lot of terraces for people to relax on with friends and family, while also, discreetly hiding all the data centers housed beneath. And so, going into the specific museum design, so this was kind of exhibit mock-up that we created. So on the outside, you have more modern uses of data science, such as cloud and AI data housing, internet and big data. And as you move towards the center, you learn about early methods of data collection and very basic math and algorithms that kind of hold up all of these data science systems. So we wanted this waterfall in the center to kind of just be another element of beauty for the area. And so water is pumped from the river that runs through the design, through the columns, and up and around to create this. And so next we're going to talk about the internal elevations so you can get a better idea of kind of how it looks on the inside. So I created two internal elevations, elevation A and elevation B, which are two slices of our plan. And so the river kind of empties out back into Mill River, and our east-facing side of our design, which is not pictured in this conceptual drawing, will have fully solar windows to harness as much energy as possible. And then in the center will be wind turbines, but my colleagues will discuss kind of the more net zero initiatives and the wind and solar energy sources later on. So these are actually the elevations. So the top elevation is elevation A. The green areas are all the data center areas, so that's where all the data center racks will be housed. The blue areas are, purely mechanical areas for the cooling mechanisms, so such as the water being pumped through the system. The turbines are going to be kind of popping out of the water. And there's the pumping mechanism for the waterfall. And so up on the top, the purple areas are the public informational areas. So there's a bridge that connects the administrative and public area to the museum, which is on the top, and there's elevators in the columns. And then elevation B is on the more southern part of our design. And so on the top, that is an administrative area. And then there are a bunch of data center racks, and then the cooling mechanisms on the bottom to kind of make this as energy efficient as possible.
So now I think it's time to hop into our main component of our design, our net zero aspect. So how are we going to make our design environmentally friendly and able to give back to the community? So one of the main ways we decided to do this was through the use of solar energy converted into renewable energy. Now, our data center is made primarily of glass. Not necessarily the systems themselves, but rather the material we used to build the structure, such as our information center, our admin spaces, etc. So we decided to incorporate solar absorbent windows into our information center design as well as those other designs. They are a relatively new technology. They function similarly to your typical traditional window, except they have a photovoltaic glaze, which is able to convert solar energy, which is typically very common to find on Long Island Sound, into renewable energy. These windows are also equipped with sensors that can detect and manage energy use within our buildings. So if we have excess energy use, it will be able to reduce it. These windows will span the entire major wall of our design, the east-facing wall, which wasn't shown in the floor plans, but is most certainly there, as well as encased museums info centers, cover admin areas, and encased bridges across the gap. Our bridge is shown in the floor plans earlier. Any excess electrical energy will be fueled back into the grid, and we will use that energy to give back to the surrounding community so they can source from that energy that we are not using. Additionally, there will be solar panels on the roof of the museum, which will ultimately serve to convert more solar energy into renewable energy. Typically, solar panels are able to convert 17 to 23% of solar energy into renewable energy, but commercial grade solar panels can traditionally convert more. We also wanted to capitalize on the fact that our data center is located in Cook Point, Stanford, so right on the Long Island Sound, and use wind energy, convert that into renewable energy through turbines. Now, horizontal wind turbines are bulky, slightly ugly, and a disturbance to the surrounding community, which is important considering this is downtown Stanford. So we decided to use vertical axis wind turbines, specifically Darius turbines, which can be identified by those two curved points there. Will allow for increased torque and power output with average wind speeds. And again, considering you are located right on the Long Island Sound, your wind speeds are going to be above average most of the time. However, they will be able to perform efficiently even when that is not the case. With the omnidirectional design of the rotor blades allowing for wind to be picked up from any direction, it is an overall efficient energy resource, along with environmentally friendly. Now, again, the difference between vertical axis wind turbines and horizontal wind turbines is communal impact. These are not disturbing the surrounding community, they are quiet, they are efficient, and they can harness almost as much energy as those big, bulky horizontal wind turbines, and overall eradicating the threat of noise pollution. Now, one of the main components of a data center, which everyone seems to talk about, is water. We, obviously located on the Sound, wanted to pull water from the Sound in order to cool our data centers. However, we do understand that the environmental impact of this can be sufficient if not handled correctly. So there are two sections to this part. First, we are going to focus on cooling. When you're pulling water from the Sound, you have to keep in mind that the salinity concentration of the water is significantly high, which can cause the pipes we use to corrode over time, very quickly over time. And our data center is going to be well equipped with server cabinets that will house any necessary systems, such as our routers and patch panels. And in order for these systems to cool, because if they overheat, they will shut off, and it is very expensive to replace, we need water to cool them. So in order to do so, we decided to collect water from the Sound, but use reverse osmosis desalination mechanisms to convert that salt water into fresh water. So the cold water will flow from a cooling tower through industrial grade pipes into a chiller. The water cools the air in the chiller, and the cold air travels downward through raised floors, is pressurized and delivered to the cold aisles of the data center. So as you can see here, there are hot aisles and there are cool aisles. So when the water flows down, they flow through, the cold air will flow through perforated tiles, cooling your server racks and systems, and the hot air will flow through vents in the ceiling. The water, which is now heated, will flow back through your pipes and go back to the cooling tower to be cooled again. We will talk about the recycled water aspect in the next slide. So our use of recycled water, as demonstrated in the waterfall aspect of our final design, holds significant environmental benefits. So the water flows through the canal as shown in our floor plans into underground pipes built from galvanized steel to prevent corrosion, and they flow into industrial grade reverse osmosis desalination machines. So these machines apply pressure on the water in order to filter out a highly concentrated, high salinity concentrated water and allow fresh water to flow through to our cooling systems. This high salinity concentrated salt water will be pushed through another tube and used to create salinity gradient energy, which is another power source with zero pollute emission. The fresh water will travel through pipes and serve to cool our data center and provide additional plumbing to information center facilities and museum facilities, while the concentrated salt water will power our MEP system through reverse electrodialysis, RED. So in addition to our sourced solar energy and wind energy, this mixes two solutions with different salinity to produce renewable energy. So in order to do this, you can have two reverse osmosis desalination machines which pull water at different levels from the Sound, because salt is pretty dense, so when you have salt and water, it will sink. So the lower you go in the Sound, the more salt you'll find. So if you pull water from a tube closer to the surface of the Sound, and then you pull water from the tube closer to the bottom of the Sound, you'll have two different solutions with different salinity concentrations. And this will be able to produce renewable energy through our RED systems. So the seawater, once it served its intended purpose, then flows back into our galvanized pipes, down the waterfall, through cooling tanks, and is pumped back in the chillers to be used again. And our server layouts. So server cabinets have an average measurement, 73.5 inches in height, 19 inches in width, and 42 inches deep. and because of this, they're estimated to take up around 204,219.74 square feet of our overall plot of land in total. This is taking into account, obviously, the average server cabinet size and the estimated need of 37,130 total server cabinets. This estimation also takes into account the calculated surface area of a single server cabinet, which is 798 square inches, and when you convert it to square feet, 5.5, you're able to divide this by the estimated square footage that the cabinets will take up. So each server cabinet holds 42 units total. And these are the turbine locations. So when we were placing these, we decided to take into account aesthetic, obviously. We wanted to keep them out of the way enough so that they are not an eyesore to the general public, but in a space that made the most sense, considering that this border right here also borders directly on the sound. So people who are looking out the windows can see the turbines, but people who are looking from the street won't be able to do so.
Okay, so now moving on to our budget, this is a really big part of it because there are so many, as my colleagues previously shared, there are so many components to this data structure that eventually we combine to make our budget. So our total estimated budget is around 440 million for this data center. A large part of it, around 150 million, goes to the underground structure, to the part you don't even see. Because the data center is below an artificial hill, in part the project requires deep excavation of it, which means like a lot of digging, and you have to reinforce concrete walls, waterproofing, and structural support. Because the project is right by the Long Island Sound, the soil is not really stable, so a lot of the money, or a lot part of our budget goes to stabilizing it and making and reinforcing it, so it's stable for our artificial hill and park. And then another 30 million goes to preparing and studying the surrounding environment and flood protection, since the project is so close to the Long Island Sound, which increases the risk of water intrusion. About 170 million is to the MEP systems that keep the data center running. These systems include the cooling system, like the chillers, the pumps, and the air handling systems that reduce the heat produced by our roughly 37,000 server cabinets. And part of the cooling process also uses, as we said, the filtered seawater through reverse osmosis desalination. And the electrical systems include the transformers, the backup batteries, and equipment that distribute power throughout the data center, so that if there were ever a power outage, the data center keep running. The remaining 90 million goes toward the computing infrastructure, renewable energy systems, and the public spaces. Around 55 million goes to server racks, fiber optic networking, and other data equipment. And then the other things goes to like our net zero aspect of it, our funds, our solar panels, and the windows, and the wind turbines. So this is a schedule. It's roughly a 6-year schedule divided into 4 quarters for each year, so 24 quarters in total. The first year is considered like, I can call it like the research year. It's around more focused on like the research aspect of it and the preparation of the actual site. So quarter 1 is the initial concept design and the environmental studies and site analysis. Quarter 2 is the architectural design, development, and engineering planning. Quarter 3 is the environmental impact studies and the permitting, because to make a project, especially one of this thing, you have to get your permits. And then quarter 4 is finalizing the designs for it. The second year is more like preparation of the actual site. So quarter 1 is land clearing and initial site preparation. Quarter 2 is soil stabilization and through system installation. And quarter 3 is large scale excavation. And quarter 4, foundation, stabilizing the foundation. Year 3 is more focused on like the base and construction, the actual shell of the underground portion of our project. And then year 4 is the completion of it, is the initial preparation of our overground aspect, including the artificial hill and park. Year 3 is the building and installation of a lot of our systems, like our cooling systems, our mechanical and electrical systems. And then the 6th and final year is the finalization of our museum and our informational data center. And yeah. And so some challenges we faced was when we first began our initial design, we struggled to come up with a way we could incorporate the liquid cooling systems into our data center without causing harm to the surrounding area. That's where the idea to incorporate the waterfall along with the reverse osmosis desalination mechanisms. Recycling water while simultaneously using the salt to generate renewable energy. Coming up with the overall design also proved to be a challenge. We were kind of stuck between doing a full above ground design and an underground one. So we both had the pros and cons, but in the end we decided that an underground design would assist with the cooling while also freeing up the surrounding areas, not just for our turbines, but trees and other plants as well, further aiding our net zero commitment.
So yeah, that was our presentation on the net zero data center. Do you have any questions?
That was impressive. There's a lot of technology in there. As you're going through, I think that you're doing quite a lot with it. Would this be data center? Would it be a traditional data center or an AI data center? Or you hadn't figured that part out?
So that part isn't necessarily specified. The problem with data centers is that you can do one of two things with them. You can either dedicate one data center to a specific company, so that company owns, or you own all the servers, but that company uses all the servers, which is easier security-wise. Or you can house multiple companies within that one data center. Problem with that is it poses some security risk. You have to make sure that these different companies have different security measures for each server rack they own. It doesn't matter what necessarily the data center is used for, just who is using it and how many people are using it.
No, it's interesting. The one thing that struck me was sort of it's going for farther on, the windmill, the turbine. I pulled back on that, not because of criticism of the turbine, because when you get into this and you are really trying to bring this into the community, you've got so much stuff going on there that what the entity will become really is or want to become is sort of a trusted expert in certain areas. And one of the big critical areas for the data centers is the water element, and you're trying to work on that, plus make it carbon neutral. But when you focus, I love the idea of the water water park, I'll call it. It's not that, but you're utilizing that on there because it's sort of it pushes out of confidence. We can take care of the thermal stuff on there, and we can develop on there. So when you're doing that, the amount of I was thinking, thermal engineers, maritime or marine biologists that you're doing on there, the amount of really closeness that you'll be working with the industry and the fisheries and stuff like that. That's where your real expertise would want to come, as you're saying that you can get through this as you get through your regulatory approvals. And you can start pushing large solar panels and the other element in there that fills in that element in there. But then what you really want to do is you really want to get the comfort and the trust of the maritime industry there to go through with your plan. So it's not that the windmills wouldn't work, but I think as you got into there, it would be an incredible plan, and it would be very interesting the way the organization would work on there. So it's hats off. There's a lot of technology that you guys have to look at and try to solve.
You guys did an amazing job, and the key point that I was really thinking about, and you brought it to a head, was the concentration of salt, and also the cooling aspect of the site. I think that you definitely hit that home, for real. Great job. Very good.
Thank you.
Great job on net zero team. Julian, you have selected a topic with a lot of challenges. For example, in part of design and also in part of science studies that you have done. And to be honest, it can be the project for master students in architecture, for example, to do a lot of research about this because you have brought a lot of things. Because this topic, there are a lot of students that are working on that in their master project, to be honest. Therefore, you have done a great job. You have selected a topic with a lot of challenges. Therefore, you have selected good precedents for your project. For example, in the form of the site. For example, you have selected a project from Cincinnati that almost similar form that it is really great. And another project, and then at the beginning of your presentation, you were talking about AI. I was a little panicked that probably you have used some AI rendering or something like this, but I want to say that you have done a great job about your hand drawing. And I can say in architecture, hand drawing, they have a lot of values. Therefore, it has been really difficult to show a lot of terrains, how these terrains, they are connected, for example, how they are connected within the space, within the heart of the building that we have over there. Therefore, this is really great, and I am happy that you have brought some sections, because you are showing your ideas through the section. Therefore, we see the value of the sections, that sometimes it is becoming more important than pen drawing, and then this is great. And then about the research, you are showing the influence of water as a part of the sustainable design in your section drawings. That this is amazing. That I really enjoyed that part. Therefore, just one comment for you about type of turbines that you are using and the shape of that. IQ has shown us that where you are implementing them, for example, probably because of the big shape of these devices, I think it is influencing your design probably, and it can be part of your design. And I am sure that, for example, in the next step, when you are thinking about the implementation of these turbines, for example, probably we can have some spaces for that. Or if you have thought about that, you can share with us.
Thank you. It was kind of highlighted on that map over there. Here. Right here, so the highlighted spaces would be where the wind turbines would be located. We tried to keep them as out of sight as possible for the general public, so it's not, again, necessarily an eyesore. They're pretty big, but they do come in different sizes. So the bigger ones are able to harness more energy. We believe those would go into the canal area, so they're further down in the ground, so they're still big, they're harnessing a lot of energy, but they're more hidden. And then the smaller ones could be used on those highlighted areas on the land, which serves both environmental sustainability and aesthetic purposes.
Great, thank you.
Just like quickly adding on, I think also what's important to highlight is kind of like taking inspiration from the Serpentine walk from Cincinnati. Is a lot of the places people are going to be congregating isn't going to be where those turbines are. So those turbines are kind of in the back area. And I think the main like public area, the main park area that we try to highlight through our design is this area up here in the front. And so in the back, that's going to be kind of not as accessible to people. So that's going to be where the turbines are housed, where people are going to be gathering. Is going to be more over here.
You are correct. Since you are talking about water, probably think that it's kind of nature, wind, for example, because you are highlighting about the water and you are talking about wind, for example, how it is influencing just for example, that probably you could highlight also the role of wind, for example. But by the way, great.
Thank you very much, Data Harbor team. So last but not least,